It is an exciting thing to boot an operating system that has not been booted for probably close to 40 years on near original hardware. This is what happened with the MIT Small Incompatible Timesharing System, or otherwise SITS, an operating system that apparently only ever ran on one pdp-11 45 until just a few days ago. This particular operating system was made as part of the MIT Logo Lab's effort to develop the Logo programming language. The operating system is inspired by the famous, or perhaps infamous, incompatible time-sharing system for the pdp-10. Since the instruction sets are different, it's a recoding. But it is similar in nature. Much of the same commands are used, and some of the internal concepts are similar. SITS has been kept on ice for a long time as disk and tape images that have been archived by one of the original developers, Ron Lebel. He's made those disk and tape images available to us, and we've been slowly getting the system to work on the SimH emulator. Not long ago, Lars Brinkhoff was able to get SITS booted and even Logo running on SimH. I've taken the disk images that he produced and have copied them over to my pdp-11 45 in a hope to get it to run on the original CPU. My CPU does not have all the capabilities that SITS requires, and SITS is quite particular about the kind of hardware that it boots on. Fortunately, I'm not the only one who is interested in ancient hardware, and in pdp-11s in particular. I'm also not the only one who finds that they have a machine that is not quite complete. My machine does not have very much memory and does not have any mass storage devices. And as far as SITS is concerned, it also lacks the custom vector and raster graphics that were necessary to run Logo. SITS will not boot without them. Additionally, SITS will not boot if the exact amount of memory is not found. It wants to see 216 kilobytes of memory. No more, no less. That presents some rather unique challenges for which there is a unique solution. Jörg Hupp has made a device that he calls the Unibone. It's a board that plugs into the backplane of the pdp-11 and can emulate in software just about any device you can imagine. This has made my machine able to boot various operating systems because it supplies the mass storage hardware. I wrote some stubs, devices that do not actually do anything except respond to the memory addresses that are required, for the MIT vector graphics devices and raster graphics devices, as well as one of the serial interface boards that the operating system expects. With these in place, it is possible to boot the operating system. So, enjoy. My machine has the pdp-11 CPU, the standard device for that. It has no fast memory, or semiconductor memory would be on a separate but effectively parallel bus. Instead, it just has 32 kilobytes of core memory. Now, since SITS requires 216 kilobytes, the Unibone supplies the rest as, in fact, somewhat fast memory. There are two serial ports, one of which is used for this experiment. That's the one with the red cables, so the one that is to the right. There's a boot ROM card, which is not used for this particular demonstration, and there is a clock. The clock takes its time from the 60 Hertz power line signal. Unfortunately, I have no floating point processor. That's a several board device, and so I'm not able to run Logo, and as it turns out, I'm also not able to run the debugger. You will notice that the serial ports and are devices that do not have many cables leading out of them. SITS actually wants a multi-port terminal adapter called a DH11. I don't have one. Additionally, there are no boards here for running the custom MIT vector and graphics displays. All of these devices are currently stubs provided by the Unibone. So what that means is it responds to the bus for the addresses that would be where those devices live, and it does nothing aside from responding, saying that all is well. As it turns out, SITS is none the wiser. The first step is to set up the Unibone device. This device has its own interface and contains several different emulated devices that need to be started. Each of these devices are controlled from a menu-driven interface, and you can see at the top several virtual devices that are stubs for the MIT display devices as well as the pdp-11 device. You could also load the bootloader, the rug debugger. Now that everything is loaded, we can dial in the address of the bootloader and start the program. The prompt for this is a simple star. We can type in the commands to get SITS booting. At the suggestion of Brian Silverman, we use the Salvager tool to get started. It appears not to be necessary, but it works just fine and has the added benefit of checking the disks. The light pattern changes abruptly once timesharing starts, and we get the message, SITS is up. We can get the system's attention to log in by pressing Ctrl-Z. Directory listings can be explored with the directory editor. This program has a bit of strange syntax. But the SITS file system has a hierarchical structure. Here we attempt to start Logo, so you can see what the booting process for Logo looks like. It won't succeed because there's no floating point processor. Unfortunately, you get kicked back into Rug, which is the basic debugger, and from there, booting back into SITS is not too hard, it's just the same process as before. Anyone who has played with ITS knows that the main command prompt is the debugger DDT. SITS has this debugger, and it works in SimAge if you have the floating point processor. Unfortunately, I don't, which causes another crash, and we'll have to reboot once again back into SITS. Once again, SITS is up, and
and we can get its attention with Control-Z. Here I am exploring the other disks, and you can see there's not much on them. And as it happens, you can't bring down the SID system. It just says no. Oh well.